Why is European Space Agency, ESA, launching a never-before-attempted mission called Comet Interceptor? ESA is preparing to wait in deep space for a comet that's never been seen before, a pristine visitor carrying secrets from the dawn of our solar system. Meanwhile, NASA is gearing up with missions like Deep Impact, and China's space agency is planning its ambitious comet study, each pushing the envelope to understand these icy time capsules. But only ESA Comet Interceptor is designed to lie in wait at the Sun-Earth second Lagrange point, ready to intercept the next newly discovered comet, or perhaps even an interstellar visitor. Today, you're going to learn comet anatomy, from nucleus to twin tails, the story of iconic comets like Halley's Comet. Stick with us, because the next frozen messenger from the edge of our solar system is about to tell us how we began. In the vast, silent theater of the cosmos, there are travelers. They journey across unimaginable distances. They move through the darkness between worlds, unseen for millennia. These are the comets, ancient wanderers of our solar system. They are not stars, nor are they planets. They are something else entirely. They are ghostly emissaries from the farthest, coldest reaches of our cosmic neighborhood. For most of their existence, they are invisible, frozen, and quiet. But every so often, one begins a long fall toward the sun, and a celestial story begins to unfold across the night sky. These cosmic pilgrims appear suddenly in our heavens. They arrive without fanfare or warning. One night the sky is familiar. The next, a new, faint smudge of light has appeared among the stars. This visitor grows brighter, night after night. It develops a magnificent glowing tail that stretches across the constellations. It captivates our gaze and sparks our imagination. For a few weeks or months, it graces our sky, a temporary beacon in the profound darkness. Then, just as mysteriously as it arrived, it begins its long journey back into the abyss, fading from our sight once more. What are these ethereal objects? Where do they come from, and what secrets do they carry? They are more than just beautiful sights. They are messengers from a forgotten era. Each comet is a time capsule, a frozen relic from the very birth of our solar system, over 4.5 billion years ago. They are leftovers from the great construction project that built the planets, including our own Earth. They witnessed the dawn of our sun and the formation of every world we know. Their icy hearts hold the chemical clues to our own origins, preserved in a deep freeze for eons. This journey is a voyage to understand these silent storytellers. We will travel with them from the dark frontiers of the solar system to their brilliant encounters with our sun. We will explore their very essence, from their solid, frozen cores to their spectacular, glowing tails. We will uncover the stories they have told to civilizations throughout history and the scientific truths they are revealing to us today. Join us as we chase the comets, these silent messengers from the dawn of time, and listen to the cosmic tales they have waited billions of years to share. Imagine a celestial ghost, a hazy, luminous presence in space. This is a comet, named from the Greek word for long-haired. Unlike stars or planets, a comet is a transient spectacle. These cosmic snowballs spend most of their lives in the cold darkness, invisible until their orbit brings them closer to the sun. The sun's energy transforms the ice into gas, creating a glowing coma. We are seeing a ghost made of gas and dust, slowly disintegrating as it passes the sun. Their beauty is a sign of their slow, inevitable demise. To truly understand a comet, we must journey back in time. Not just centuries or millennia, but billions of years. We must travel to the very beginning of our solar system. Before the Earth, before Jupiter, before any of the planets existed, there was a vast, swirling cloud of gas and dust. This was the solar nebula. It was the cradle of our sun and all its future worlds. It was here, in this primordial cloud, that our story begins. And it is in this same cloud that the comets were born, alongside the planets they would one day visit. As the young sun ignited at the center of this nebula, the process of planet formation began. Tiny grains of dust and ice started sticking together. Through a process called accretion, these small clumps grew into larger ones. They formed planetesimals, the building blocks of planets. In the warmer, inner regions of the nebula, rocky planetesimals formed, eventually creating Mercury, Venus, Earth, and Mars. But in the colder outer regions, beyond the frost line, the building materials were different. Ice was abundant, mixing with rock and dust. Here, icy planetesimals took shape. These icy planetesimals are the ancestors of the comets we see today. They are the leftover construction materials from the era of planet building. While many of them were incorporated into the giant outer planets like Jupiter and Saturn, countless others were not. They were scattered by the immense gravity of these newly formed giants. They were flung into the farthest, darkest corners of the solar system. There, they have remained in a state of suspended animation, orbiting the sun in a deep freeze for over 4.5 billion years, waiting patiently in the dark. Every comet that graces our sky is, therefore, a direct link to this ancient past. It is a pristine sample of the original solar nebula. It carries the chemical fingerprint of the materials that built our entire planetary system. When we study a comet, we are not just looking at an object, we are looking at a piece of history. We are analyzing a message from our own cosmic origins. What hidden stories lie frozen within a comet's heart? By studying these icy relics, we are piecing together the story of our own beginnings, one frozen messenger at a time. For most of human history, the sky was a realm of perfection and predictability. The stars wheeled in their fixed patterns. The sun and moon rose and set with comforting regularity. The planets, the wanderers, followed complex but understandable paths. This celestial order was a source of stability and meaning. Then a comet would appear. It was an intruder in this clockwork universe. It followed no known rules. It blazed across the familiar constellations, a celestial exclamation point that seemed to demand an explanation. Its sudden arrival was often seen as a disruption of the natural order. Throughout cultures and across continents, the appearance of a comet was an event of great significance. It was rarely seen as a good thing. To many ancient civilizations, it was a cosmic omen, a sign from the gods. Its fiery tail was interpreted as a celestial sword, a harbinger of war, famine, or the death of a king. The Romans recorded comets appearing before great tragedies. In China, court astronomers meticulously documented these broom stars, believing they foretold events on Earth. A comet was a message written across the heavens, and humanity struggled to decipher its meaning. This fear and awe were rooted in a lack of understanding. Without the tools of modern science, our ancestors could only interpret these events through the lens of mythology and superstition. The comet was an anomaly, a cosmic wildcard in an otherwise orderly sky. It defied their understanding of how the universe was supposed to work. This made it powerful. It was a visible reminder that there were forces at play beyond human control, forces that could interrupt the divine harmony of the heavens without warning. This celestial spectacle was both beautiful and terrifying. Today, our perspective has changed. We no longer see comets as omens of doom. We see them as objects of scientific inquiry. We understand their orbits, their composition, and their origins. Yet, a trace of that ancient awe remains. When a bright comet appears in our sky, we are still captivated. We still feel a sense of wonder at this visitor from the deep. It connects us to our ancestors, who looked up at the same sky with a mixture of fear and fascination. The comet is no longer an omen, but it remains a profound symbol of the vast, mysterious, and powerful universe we inhabit. While our ancestors saw divine messages in the sky, we now seek scientific data. A comet is no longer a portent of destiny, but a frozen archive of cosmic history. Each one is a time capsule, perfectly preserving the conditions of the early solar system. For billions of years, these objects have been stored in the coldest regions imaginable, far from the sun's altering heat. This deep freeze has kept their original chemistry locked away, unchanged since the time the planets were first forming. They are pristine relics, holding the raw ingredients of our cosmic neighborhood within their icy bodies. These frozen archives contain a wealth of information. By analyzing the light that reflects off a comet and the light emitted by its gas and dust, we can determine its chemical makeup. We have found that comets are rich in water ice, but they also contain a fascinating cocktail of other substances. We find frozen gases like carbon dioxide, carbon monoxide, methane, and ammonia. We also find a complex mix of organic molecules, the carbon-based compounds that are the fundamental building blocks of life as we know it. These are the very molecules that form amino acids and proteins on Earth. The presence of these materials in comets raises one of the most profound questions in science. Could these ancient travelers hold the keys to understanding where we come from? The early Earth was a hot, violent place. It is possible that many of the original building blocks of life were destroyed in this chaotic environment. Some scientists hypothesize that comets crashing into our young planet could have delivered a fresh supply of water and organic molecules. This idea, known as panspermia, suggests that comets may have seeded the early Earth with the necessary ingredients for life to begin. Unlocking these frozen archives is one of the great quests of modern planetary science. We no longer wait for comets to come to us. We send robotic explorers to meet them. Spacecraft have flown past comets, flown through their tails, and even landed on their surfaces. These missions are our tools for reading the ancient text frozen within a comet's nucleus. They are our way of directly accessing this 4.5 billion-year-old history book. The story of comets is becoming our story, a tale of cosmic origins and the intricate connections that bind our planet to the wider universe. At the center of every comet lies its solid, frozen core, the nucleus. These nuclei are among the darkest objects in our solar system. They are surprisingly small, typically only a few kilometers across. Comet nuclei are not perfect spheres, often described as looking like a potato or a peanut. It is often called a dirty snowball, an aggregate of ice, rock, and dust. This composition is a direct sample of the primordial cloud from which our solar system was born. The story of a comet's brilliant display is the story of its nucleus. As the comet's orbit carries it closer to the sun, a remarkable transformation begins. The sun's radiation gently heats the dark surface of the nucleus. This warmth penetrates the insulating crust, reaching the pristine ices buried beneath. These ices do not melt into liquid. In the vacuum of space, they undergo a process called sublimation, turning directly from a solid into a gas. This gas, a mixture of water vapor, carbon dioxide, and other volatile compounds, erupts from the surface, carrying with it a cloud of fine dust particles that were trapped within the ice for eons. This expanding cloud of gas and dust forms a vast, glowing atmosphere around the tiny nucleus. This is the coma. It is what gives a comet its characteristic hazy, ghostly appearance. While the nucleus may only be a few kilometers wide, the coma can swell to an enormous size, often becoming larger than the planet Jupiter. It is a temporary, tenuous atmosphere, a shimmering shroud that completely obscures the solid heart within. The coma is the first visible sign that a distant, frozen object has awakened and is beginning its celestial performance for all to see. The coma shines for two reasons. First, the countless tiny dust particles within it are excellent at reflecting sunlight, creating a diffuse white or yellowish glow. Second, the gas molecules within the coma are energized by the sun's ultraviolet radiation. This solar energy excites the gas, causing it to fluoresce, much like the gas in a neon sign. It emits light at specific wavelengths, giving the coma a distinct, often greenish tint. This beautiful color is typically caused by the fluorescence of diatomic carbon and cyanogen molecules, products of more complex organic compounds breaking down under the sun's glare. The size and brightness of the coma are not constant. They depend entirely on the comet's distance from the sun. As the comet races inward, the sublimation rate increases dramatically, and the coma grows larger and brighter. As the comet swings around the sun and begins its long journey back into the cold darkness, the process reverses. The heating subsides, the sublimation slows, and the magnificent coma begins to shrink and fade. It is a dynamic, ever-changing feature, a glowing breath that the comet exhales only during its brief visit to the inner solar system. As the comet nears the sun, it is not just sunlight that it encounters. It also flies into a continuous stream of charged particles flowing outward from the sun. This is the solar wind, a fast-moving river of protons and electrons that permeates the entire solar system. This powerful wind interacts directly with the gases that have sublimated from the nucleus and now populate the coma. The solar wind is a force of nature, and it sculpts the comet's atmosphere, creating one of its most striking and beautiful features, the ion tail, also known as the plasma tail. The process begins when intense ultraviolet light from the sun strips electrons from the gas molecules in the coma. This process, called ionization, transforms the neutral gas atoms into positively charged ions. These newly formed ions are now electrically charged, and they can be grabbed and carried away by the magnetic fields embedded within the solar wind. The solar wind effectively sweeps these ions straight back, away from the coma, forming a long, straight, and narrow tail that can stretch for tens of millions of kilometers through space, like a celestial streamer. This ion tail is a ghostly and ethereal sight. It glows with a distinct blue light. This color is not from reflected sunlight, but from fluorescence, similar to the process in the coma. In this case, it is primarily ionized carbon monoxide molecules that, energized by solar radiation, emit a characteristic bluish luminescence. Because the ion tail is composed of such lightweight charged particles, it acts like a cosmic windsock. It always points directly away from the sun, regardless of the direction the comet itself is traveling. This means that as a comet moves away from the sun, it can actually be flying in front of its own tail. The ion tail is also a dynamic and turbulent feature. It often displays intricate structures of knots, kinks, and streamers. These are visible records of the gusty and variable nature of the solar wind itself. On rare occasions, a particularly strong blast from the sun, known as a coronal mass ejection, can completely sever the ion tail from the comet's head, an event called a disconnection. A new tail will quickly begin to form in its place. This ghostly blue appendage is not just beautiful, it is a visible manifestation of the invisible forces that dominate interplanetary space. The gentle pressure of sunlight acts on the comet. Photons carry momentum, exerting a tiny push. Radiation pressure affects lightweight dust particles escaping into the coma. This creates the dust tail, often the most visually impressive part of a comet. The dust tail is broad, diffuse, and gently curved. It marks the comet's path. When Earth passes through these trails, we see meteor showers. The particles burn up as shooting stars. The surface of a comet's nucleus is not a uniform landscape. It is a complex terrain of different materials and structures. As the nucleus rotates, different regions are exposed to sunlight. Some areas are covered in a thick, dark, insulating crust that heats up but does not release much gas. Other areas, perhaps weaker spots in the crust or freshly exposed patches of ice, are far more active. When sunlight hits these volatile regions, the sublimation of ice can become concentrated and violent, creating powerful jets of gas and dust that erupt from the surface. These jets are like geysers on a frozen world. They are focused streams of material that shoot out from the nucleus at high speed, often several hundred meters per second. They can be seen in close-up images of comets as bright fan-shaped plumes extending from the sunlit side of the nucleus into the coma. Because the nucleus is rotating, these jets often spray material out in a spiral or pinwheel pattern, contributing significantly to the structure and density of the inner coma. These jets are the primary engines that feed the comet's magnificent tails. Sometimes, a comet's activity is not so predictable. A comet that has been behaving normally can suddenly and dramatically increase in brightness, sometimes by 100 times or more, in just a matter of hours. This is called an outburst. These events are thought to be caused by sudden, catastrophic releases of gas and dust. Perhaps a large section of the comet's surface crust collapses, exposing a huge reservoir of highly volatile ices to direct sunlight. Or maybe a pocket of trapped gas, warmed by the sun, finally builds up enough pressure to violently explode. These outbursts make comets famously unpredictable. Astronomers can model a comet's orbit with great precision, but predicting its brightness is far more difficult. An outburst can transform a faint, telescopic object into one that is easily visible to the naked eye overnight. This unpredictable behavior is part of what makes comet watching so exciting. Each comet is an individual with its own unique personality and potential for surprises. These jets and outbursts are a powerful reminder that these are not dead, inert objects, but active, dynamic worlds undergoing profound changes. When we observe a comet, we see a celestial object with a rich palette of colors. Each color tells a story about the comet's composition and its interaction with the sun. The green coma is from molecules broken down by sunlight. The blue ion tail shines from carbon monoxide ions. The yellowish-white dust tail is simply reflected sunlight. Together, these colors create a stunning spectacle, revealing the science of a comet's anatomy. To find the birthplace of comets, we journey far beyond the familiar planets, past Mars, Jupiter, and Saturn, to the solar system's true frontier, a cold region where the sun is a distant star. Here, trans-Neptunian objects, leftovers from the solar system's formation, wait. This is the source of comets, preserved in a cosmic freezer. Two reservoirs exist, the Kuiper Belt and the distant Oort Cloud, the starting point for journeys that transform frozen relics into brilliant messengers. Our first stop is the Kuiper Belt, a vast, icy disk beyond Neptune, home to countless frozen relics from the solar system's birth. Here, dwarf planets like Pluto reign among millions of smaller bodies, many destined to become short-period comets. Neptune's gravity can nudge these objects, sending them on new orbits toward the sun. This is how a quiet Kuiper Belt object transforms into a spectacular, recurring comet. The Kuiper Belt is both a graveyard and a launch pad for some of the solar system's most dazzling visitors. Far beyond the Kuiper Belt lies the Oort Cloud, a vast spherical shell of icy bodies, nearly a light year from the sun. These are ancient exiles, flung here by the gravity of the giant planets during the solar system's chaotic youth. Occasionally, a passing star or the gentle pull of the Milky Way disturbs their orbits, sending a long-period comet on a one-way journey toward the sun. These comets arrive from all directions, pristine messengers from the dawn of time. Their rare visits light up our skies, offering a fleeting glimpse into the solar system's earliest days. A comet's journey begins with a subtle push, a gravitational nudge. In the Kuiper Belt, Neptune's pull can destabilize orbits, sending icy bodies inward. In the Oort Cloud, the galactic tide or a passing star can trigger a comet's long fall toward the sun. These random cosmic events set ancient objects on a spectacular fiery path. With just a whisper of force, a sleeping giant is awakened. Once nudged, a comet embarks on a slow, epic descent from the solar system's edge. For eons, it remains a frozen, silent traveler, accelerating as it nears the Sun. Crossing the orbits of the giant planets, the comet's speed and temperature rise. Near Jupiter, it approaches the frost line, where the Sun's warmth will soon awaken it. The long, cold journey is ending. A dramatic transformation is about to begin. Entering the inner solar system, the comet faces intense solar heat and planetary gravity. Jupiter can alter its fate, capturing, deflecting, or even hurling it toward destruction. Some comets collide with planets or the Sun, ending in spectacular impacts. Survivors lose mass and brilliance, fading as they retreat to the outer dark. Each passage leaves the comet changed, its ancient secrets scattered across the solar system. As the comet nears the Sun, it crosses the frost line, where volatile ices begin to vaporize. Pressure builds beneath its crust, cracking the surface and releasing gas. A glowing coma forms, shrouding the nucleus in a misty veil. The comet transforms from a silent relic into a brilliant living phenomenon. Its secrets, locked away for eons, now stream out into the solar system. As the comet plunges deeper into the inner solar system, passing the orbit of Mars, the Sun's influence just intensifies with every passing moment. The gentle warmth it felt before now becomes, well, a relentless fiery breath. Solar radiation, a constant stream of light and energy, pours onto the comet's nucleus. This energy is absorbed by the dark surface, heating it to temperatures far above the deep freeze of its home. The most abundant ice within the nucleus, water ice, now reaches its sublimation point. A dramatic and powerful transformation begins, one that will turn the comet into the spectacular object we see from Earth. The process of sublimation escalates, honestly, exponentially. It's no longer a gentle seep of gas, but a furious eruption. Across the sunlit side of the nucleus, tons of water ice per second flash directly into vapor, exploding outward into the vacuum of space. This violent outgassing carries with it a huge amount of dust and rock grains that were frozen within the ice. The comet is now shedding the very substance of its being, a constant shower of ancient material liberated from its billion-year confinement. The nucleus becomes a dynamic, chaotic engine, driving the formation of its own magnificent display. This furious outgassing rapidly expands the coma, the glowing atmosphere surrounding the nucleus. What began as a faint haze now swells into a colossal cloud of gas and dust, growing larger and brighter by the day. This expanding shroud can reach incredible dimensions, often dwarfing the largest planets in our solar system. The coma becomes a brilliant beacon, shining brightly as it reflects the intense sunlight. It's this glowing head that often first catches the eye of astronomers. A luminous announcement that a visitor from the cosmic depths has truly arrived and awakened. Within this brilliant cloud, a beautiful chemical process unfolds. The sun's ultraviolet radiation, a high-energy component of its fiery breath, breaks apart the water and organic molecules released from the nucleus. This process, called photodissociation, creates simpler, often unstable molecules like diatomic carbon and cyanogen. These new molecules are then energized by sunlight and begin to fluoresce, emitting a ghostly light of their own. This is what gives the heart of the coma its characteristic and beautiful greenish hue, a color signature that tells us we are witnessing the fundamental chemistry of creation. As a comet approaches the sun, it develops iconic tails. These tails are sculpted by the solar wind, a stream of charged particles, and the pressure of sunlight. The solar wind ionizes gas, creating a straight blue ion tail that always points away from the sun. Sunlight pushes dust particles, forming a curved, yellowish-white dust tail that lags behind the comet. The result is a beautiful display of two tails, each shaped by different forces. The comet is transformed into a dynamic system, painting light across space. The comet puts on a celestial performance. Reaching peak activity as it approaches the sun, its coma is large, tails are long, a shimmering banner across the cosmos. The comet's appearance shifts, responding to the solar wind. The nucleus contributes to the drama as different regions are exposed to the sun. Sometimes, a crust collapse leads to a sudden outburst, brightening the comet. This grand performance is fleeting, a short burst of life. As it swings around the sun, its performance winds down, signaling a return to slumber. The awakening of a comet is not a single event, but a complex symphony of interacting forces. At the heart of it all is the sun, the great conductor of this cosmic orchestra. Its gravity dictates the comet's path, pulling it from the depths of space. Its radiation provides the energy that drives the entire process, turning solid ice into gas. Each force plays a distinct part, and together they create the harmonious, multi-layered phenomenon we observe. Understanding this symphony is key to understanding the very nature of comets and the environment in which they travel. The primary melody of this symphony is the process of sublimation. This is the foundational science that underpins everything else. As solar energy heats the nucleus, the phase transition from solid ice directly to gas creates the raw material for the coma and tails. The rate of this sublimation is a delicate function of the comet's distance from the sun, its rotational speed, and the specific composition of its surface. This process is the engine of the comet, the driving beat that determines the scale and intensity of the entire spectacle, from the first faint haze to the final, brilliant outburst. Layered on top of this are the harmonies created by the solar wind and radiation pressure. These two forces take the raw material from the sublimation engine and sculpt it into the beautiful forms we see. The solar wind, a magnetic force, grabs the electrically charged ions and flings them back, creating the structured, turbulent ion tail. Radiation pressure, a force of light itself, gently nudges the dust particles, creating the serene, curved dust tail. These forces work in concert, but on different components, resulting in the two-part harmony of the comet's dual tails, a visual representation of invisible physics. This symphony also has its unpredictable, chaotic movements. The irregular shape and composition of the nucleus mean that the outgassing is not uniform. Jets and outbursts act as sudden crescendos, moments of unexpected power and beauty that can change the entire character of the performance. The awakening of a comet is a perfect illustration of the intricate physics that govern our solar system. It is a story told not with words, but with gravity, light, gas, and dust. A symphony of forces that transforms a simple frozen rock into one of the most sublime sights in all of nature. The awakening of a comet is a spectacle of profound but ephemeral beauty. Unlike the steadfast stars or the reliable planets, a comet is a fleeting visitor. Its beauty is linked to its impermanence. This ephemeral beauty comes at a great cost to the comet itself. The magnificent display we witness is the comet slowly destroying itself. It is the trail of dust left behind in the comet's wake. We call this a meteor shower. They are the legacy of long-dead comets. Ultimately, the comet's awakening is a powerful metaphor for change and transformation. It enriches our sky and our sense of wonder. For generations, the sky was both a map and a clock. The predictable motions of the sun, moon, and stars governed their lives. Then, without warning, an uninvited guest would arrive. A comet. It was a celestial anomaly, sparking questions and anxieties. Lacking scientific understanding, ancestors interpreted it through myth, seeing it as a message from the gods. Such a disruption meant something was amiss, a tear in the heavens. It was a harbinger of war, plague, or death. The comet represented the universe's capacity for unsettling change. In many cultures, a comet's tail was seen as a weapon wielded by the heavens. To the ancient Greeks and Romans, a comet was often described as a celestial sword, a divine blade ready to strike. The Bayeux Tapestry features Halley's Comet, foretelling downfall. Throughout the world, the comet's form was mapped onto powerful objects. It was perceived as a powerful agent of cosmic intervention. In Imperial China, the approach to comets was different, though no less serious. The Chinese believed in a deep connection between the heavens and the earth. a concept known as the mandate of heaven. The emperor's right to rule was directly tied to the harmony of the cosmos. So, an unexpected celestial event like a comet was therefore a matter of grave political importance. It was not necessarily a sign of certain doom, but a powerful message from the heavens that the emperor needed to heed. The cosmic order was disturbed, and it was his responsibility to understand why and to restore the balance. For over 2 millennia, Chinese court astronomers meticulously observed and recorded these celestial visitors. Their detailed records, known as the Silk Texts, are among the most valuable historical astronomical archives in the world. They did not just note the comet's appearance, they documented its color, the length and shape of its tail, and its path through the constellations. They developed a complex system of interpretation, classifying comets into different types, such as broom stars or guest stars. Each type had a different meaning, a specific warning or piece of advice for the ruling emperor. The comet was often seen as a celestial dragon, a powerful and mythical creature whose appearance could signal either good fortune or disaster, depending on the circumstances. A faint, well-behaved comet might be a positive omen, while a bright, chaotic one could signal rebellion, invasion, or natural disasters. These interpretations were taken so seriously that they could influence major state decisions, from military campaigns to agricultural policies. The comet was an active participant in the governance of the empire, a celestial advisor whose pronouncements were studied with the utmost care and respect. These ancient Chinese records have proven invaluable to modern astronomers. They provide a continuous history of comet sightings stretching back centuries before similar records were kept in the West. It was these records that allowed Edmund Halley to calculate the orbit of the comet that now bears his name, by matching its 1682 appearance with earlier sightings documented by the Chinese. This beautiful historical irony shows how a system born from astrological belief ultimately provided the crucial data for a major scientific breakthrough, bridging the gap between ancient mythology and modern astrophysics. The celestial dragon, it turned out, had a predictable path. Comets have often been seen as harbingers of great change. Their sudden arrival shattered the status quo, symbolizing a break with the past. The appearance of a comet could be interpreted as a divine seal of approval, or a sign that an old dynasty was about to fall. Consider the Great Comet of 1680. For many, it was a terrifying omen. This comet also marked a crucial turning point in scientific history. It helped Newton test his theories on universal gravitation, proving the comet was not supernatural. The harbinger of divine change became a catalyst for profound scientific change. It has always existed at the crossroads of fear and fascination, superstition and science. It changed how we saw our world and our place in a vast, law-abiding universe. The transition from viewing comets as omens to understanding them as natural phenomena was a slow process. It required a fundamental shift in the human worldview. For centuries, mythological and scientific views existed side by side. Tycho Brahe demonstrated that the comet was much farther away than the moon. This proved comets were truly celestial objects. The final blow came from Isaac Newton and Edmund Halley. Using Newton's law of universal gravitation, Halley studied historical records and predicted the return of a comet. When the comet returned on schedule, it was a triumph for science. Halley's successful prediction proved comets were predictable members of our solar system. The comet was now a natural wonder, whose secrets could be unlocked through human reason. Even in our modern age, comets inspire wonder. Though we've explained their fiery tales with physics, we have not diminished their majesty. When a bright comet graces our night sky, millions gaze upward, overcome with awe. The comet is a time traveler, carrying building blocks of our world. Great comets become global events, sparking curiosity and uniting us. They remind us we share the same sky on a fragile planet in a wondrous cosmos. Comets connect us to all who have marveled at their fleeting light. The comet's message is one of humility, curiosity, and boundless awe. In the late 20th century, humanity prepared for a modern encounter with its most famous celestial visitor, Comet Halley. We sent a fleet of robotic emissaries to study it up close. This was a rendezvous with history. The 1986 apparition proved to be a somewhat disappointing spectacle for skywatchers on Earth. An international flotilla of spacecraft, nicknamed the Halley Armada, was launched to intercept the comet. The European Space Agency's Giotto probe transmitted the first-ever close-up images of a comet's nucleus. The pictures revealed a dark, irregularly shaped body tumbling through space. Humanity saw the dirty snowball for what it truly was. Just over a decade after Halley's passage, the heavens prepared a different encounter. Discovered in 1995 by Alan Hale and Thomas Bopp, it was initially just a faint smudge far out beyond Jupiter. As it journeyed inward, it became clear that this was no ordinary comet. It was destined to become one of the greatest comets of the 20th century, visible to the naked eye for a record-breaking 18 months. Comet Hale-Bopp put on a breathtaking performance throughout 1997. Its brilliant head and two distinct, magnificent tails captivated the public imagination, connecting humanity in a way that only a truly grand cosmic event can. The Hubble Space Telescope turned its gaze toward Hale-Bopp, analyzing its light. The data revealed a massive nucleus, estimated to be about 60 kilometers in diameter. Hale-Bopp became a cultural phenomenon, a modern messenger that inspired awe. In 2020, amidst a global pandemic, a new visitor arrived. Comet Neowise, discovered by a space-based observatory, survived its close approach to the Sun. For weeks in July, it became the brightest comet visible from the northern hemisphere since Hale-Bopp. Visible to the naked eye, it was a welcome sight. Neowise became the comet of the social media era, with millions sharing breathtaking images. It brought with it pristine material from the earliest days of our solar system's formation, a fleeting gift when the world needed it most. The European Space Agency's Rosetta Mission was the most ambitious modern encounter to date. Launched in 2004, Rosetta embarked on a decade-long journey to Comet 67P, Churyumov-Gerasimenko. In August 2014, Rosetta successfully arrived. The first images were astounding. Comet 67P had a bizarre rubber duck shape. Rosetta spent 2 years orbiting this world, mapping its surface and analyzing gases. In November 2014, Rosetta deployed a lander named Philae. Philae provided the first-ever direct analysis of a comet's composition. Rosetta revolutionized our understanding of comets, revealing surface changes and confirming complex organic molecules. The mission ended in 2016 as Rosetta made a one-way trip to the comet's surface. NASA's Deep Impact mission took an aggressive approach to uncovering a comet's secrets. The mission slammed a copper projectile into Comet Tempel 1 at high speed. It studied the material excavated from the resulting crater. The impact vaporized instantly in a brilliant flash. The mission revealed a surprising amount of fine, powdery dust and water ice. Deep Impact was a success, providing a new method for studying these ancient objects. Modern comet encounters, from the Halley Armada to Rosetta, have transformed them from mysterious portents into familiar celestial objects. Each mission fuels a continuing quest to understand these messengers from the past. Future missions and new technologies aim to unlock the secrets held within these icy time capsules, including a comet sample return mission. The continuing quest also involves constant vigilance, with programs like Neowise scanning the skies to track comets that pass near our planet. They are vital clues in the grand puzzle of planetary science and astrobiology. Answering this profound question is a key driver of the continuing quest. The modern encounter is a dialogue with the past, a conversation that has only just begun. We have journeyed far, from the dark, frozen frontiers of our solar system, to the heart of a comet's awakening. We have traveled through deep time, back to the swirling nebula where these objects were born. We have seen them as omens and flown alongside them with our robotic explorers, unveiling their secrets. Comets are the great storytellers of our cosmic neighborhood. They are ancient narrators, carrying tales of creation across billions of years. Their icy hearts are archives, holding the chemical blueprint from which everything was made. When a comet awakens near the sun, it is reading a page from this ancient book aloud, telling us about the conditions at the dawn of time. By learning to read this language, we are learning about our own deepest history. It is a story of survival against the odds. We recognize that the stories of the comets are linked with our own. They may have delivered the very water we drink and the organic molecules that form the basis of our biology. To listen to a comet is to listen for the echo of our own beginning. Comets may hold clues to our origins. These icy wanderers could have delivered life's essential ingredients to a young, barren Earth. Modern encounters confirm comets are treasure troves of water ice and organic compounds, including amino acids, fundamental protein building blocks. The idea that life's ingredients were delivered from space connects our biosphere to the solar system, making every comet a potential messenger of creation. We are witnessing a cosmic process that has been happening for billions of years. While comets may be messengers of creation, they also represent a different, more unpredictable aspect of the cosmos. They are the celestial wildcards, reminders that the universe is not always a place of perfect clockwork order. Their orbits, often highly elliptical and inclined, cut across the neat, stable paths of the planets. They are intruders, agents of chaos that can disrupt the status quo. The very impacts that may have seeded Earth with the ingredients for life also represent a potential hazard, a powerful force of destruction that has shaped the history of every world in our solar system. The history of our planet is written in craters, scars left by ancient impacts from both asteroids and comets. The colossal impact that is thought to have wiped out the dinosaurs 66 million years ago is a stark reminder of the destructive power these objects carry. While that particular event is attributed to an asteroid, a large comet impact would be equally, if not more, devastating. A comet's high velocity and icy composition would result in an explosion of unimaginable scale, capable of triggering global environmental collapse. They are wildcards in the cosmic deck, and their appearance can change the game in an instant. This dual nature, as both creators and destroyers, lies at the heart of the comet's significance. They embody the profound cosmic balance between order and chaos, creation and destruction. The same process that delivers water and life-giving molecules can also bring about mass extinction. This highlights the fragile nature of our existence on Earth. We thrive on a planet that is moving through a cosmic shooting gallery, a dynamic environment where the threat of impact, though small, is ever present. This awareness fosters a sense of humility and respect for the powerful forces that govern the universe. For this reason, our modern encounters with comets are not just about scientific curiosity, they are also about planetary defense. By discovering, tracking, and characterizing these celestial wildcards, we are taking the first crucial steps to mitigate the risk. We are moving from being passive observers of cosmic history to active participants, capable of understanding and potentially influencing our own destiny. The study of comets is therefore not just about looking into the past, it is also about safeguarding our future, ensuring that these beautiful messengers remain a source of wonder, not a cause for alarm. Beyond the science, comets offer a tangible connection to the cosmos. It's easy to forget we live on a small planet adrift in an immense universe. A bright comet collapses that distance, a shared celestial event reminding us of the grander reality. This connection unites cultures and generations. Comets provide solace and wonder, a reminder of the vast universe beyond our troubles. When we marvel at a comet, We share an experience repeated for millennia. The comet is a thread of light through human history. They are more than objects. They are invitations to contemplate our place in the universe, a symbol of our deep connection to the cosmos. As our journey comes to an end, we are left with reflections in the void. Comets are like cosmic mirrors, and in their ghostly light, we see our own image reflected back at us. We see our enduring curiosity, the relentless drive to explore the unknown and to understand our origins. In their fragile and ephemeral beauty, we can see a reflection of our own planet's fragility. Earth is a rare and precious oasis in the vastness of space. Today, we have broken those bonds. The study of comets is not just an act of looking back into the past. It expands our presence and understanding beyond our home world. In studying these ancient wanderers, we are ultimately studying ourselves. The void is not empty. It is full of stories. Our exploration of comets is, in truth, an endless journey. With every mission we fly and every new object we discover, we answer some questions only to uncover a dozen more. We have learned so much, yet we have only just begun to scratch the surface of what these ancient objects can teach us. They are a boundless source of information and inspiration, a cosmic frontier that will continue to call to us, inviting us to venture further and to look deeper. The story of comets is not a closed book, but a library with countless volumes yet to be opened and read. The next generation of telescopes and spacecraft will peer into this library with ever sharper eyes. We dream of missions that will bring back pristine samples from a comet's core, allowing us to analyze the very building blocks of our solar system in our laboratories on Earth. We envision spacecraft that can hop from one active region to another on a comet's surface, studying its dynamic geology up close. The quest to understand these objects will drive innovation and push the limits of our technology, continuing the grand human tradition of exploration in the 21st century and beyond. As we continue this journey, we do so with a new perspective. The comets are no longer feared omens or passive curiosities. We now see them as integral parts of our solar system's grand, interconnected ecosystem. They are time capsules, water bearers, chemical factories, and agents of change. They are a fundamental piece of the puzzle we are trying to solve, the puzzle of how planets form, how life begins, and whether we are alone in the universe. Their story is a crucial chapter in the larger cosmic narrative that we are all a part of. So, the next time you see a faint smudge of light in the night sky, a new and temporary star with a ghostly tail, remember its incredible story. Remember the billions of years it spent in the frozen dark and the immense journey it has taken to reach our view. Think of the ancient secrets locked within its icy heart and the profound connection it represents between our world and the vast cosmos. For you are not just looking at a comet, you are witnessing the end of one long, silent journey and the beginning of our endless quest for knowledge.